Okay, so we will try to keep this quick. Those of you who may decide to tune in later, your classmates gave them the opportunity to say, this is your time, utilize it how you see fit, or would you feel more comfortable if you went over some more examples? So they said they would want a refresher, so we have no problems with that. Okay, so we'll just take this out of a different author instead. Okay, so how many liters of hydrogen gas will be produced at 280 degrees Kelvin, 96 kilopascals, and 1.74 moles of sodium reacts with excess water according to the following equation? Okay, so which I would be led to believe is probably single replacement. So what it says, okay, we have some sodium reacting with some excess water. Okay, so if you refer to this as single replacement, which it would be, okay, because sodium is so reactive when it combines with that of water. And you would have possibly remember seeing that in hunting the elements. And I think it's just human nature to always see these in videos and information like that. And probably the number one question we'll always get when they see something cool on some of the educational videos we have, what will students ask? Say that again. How you do that? Not so much how you do that. Why? Not why. What did we say over here? How? No, it's not how do they do that. For, let's say, liability reasons. You're getting closer. Can we do that? Okay, so the short answer to that is no. Okay, and with one of those aspects, I think you would agree that even sometimes, and we talk about this as a good reference with that of organic chemistry, the reactions that you undergo, sometimes they're just so unpredictable. You go through processes like this on pencil and paper, and theoretically, this is what's supposed to happen. But it's a good indication of how professors talk about it over in the lab. That's generally not how things go, okay? And what can happen, missing eyeballs, missing fingers, missing teeth, okay? And I think that stuff is cool too, okay? And even down the road at lowly Dakota State, it was the idea of my organic professor would always say, I get so nervous when we store sodium in the chemistry store closet or chemical store closet, just because based upon what you see here, what would you guess that sodium is stored in? Don't say water, or else I'm going to throw this marker at you.
A dry storage
container. You're not totally wrong, but it's not going to be a dry storage container, if that's what you said. Now I do want to throw this marker at you. Okay?
It's highly reactive.
Yes, I know.
Right.
It was a joke.
That's what I figured, but just like throwing this marker would be a joke, because I probably couldn't hit you anyway, because you're not underclassmen. We'll save that for them. Okay? But I would say what might be a stable substance to keep that? Not gasoline, not diesel. Hydrocarbon-wise, does anyone know what might be? Nope, not ethanol. A different type of fuel that's burned besides diesel and gasoline. You know it, you just don't know you know it. Nope. That's liquefied when it's under pressure. Okay? It's once you release it that it turns into a gas. That's why you can transport propane. So you're not totally wrong.
What would it just be, oxygen?
Nope. 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 How many of you have seen, per se, The Men Who Built America? Because it's a good story of how industrialization, kerosene, that's right. Sodium is actually stored in kerosene. Okay? So with this, when we talk about, yeah, these things are cool to do, but even in my own case, I do get a little nervous with students over, and that's why we wait to do some of these maybe more complex, per se, I want to say chemistry labs, especially when it comes to that centrifuge, because human nature as it is, people don't want to do that, have these on, so I used to sometimes see this a lot, or see this a lot, or put it in their pocket, okay? But that's what safety glasses are for. And at a different school, that centrifuge is actually 20 years old now, I think, or 21 years old. So it's older than you people and still held together. I don't know. I don't know how it still works either, but it just does. But anyway, it was still spinning just like you did in your chemistry lab. He probably opened it maybe just a little too early. And what happened is a glass shard had broke off and went doink, hit him right here and fell to the floor. But he had his safety goggles on. That's why you wear them. Okay, so that's an example of what I'm saying as far as, yes, we do get nervous over there. It's not that you're idiots. You're not idiots, okay? It's just sometimes things just don't go as planned as they should. Okay, so a little more context. So how many, first of all, sorry, we got to finish the reaction. If it's single replacement, what do you think is happening over here? Okay, so Na, that's, okay. This will be a little more apparent when you rewrite water. How can you rewrite the water molecule? Okay, so if we did that, okay, so notice there's a little space between these two because that's how these would split apart, because hydroxide has -1, this is +1. So how does this split apart then? Where would it split apart? Okay, so if that's where it splits apart, which it would, this sodium is going to boot what out of this molecule? Say that again. One hydrogen, not two, one hydrogen. That's important, okay? So then what does that leave left in the molecule? Right. So it's not that you're wrong, okay? We just wanted to clarify that a little bit. Now we got NaOH, okay? And then what's left over from this reaction still? Okay? So here we need to have a 2. Okay.
Is that going to be on the test?
I don't know. We want an example, so I just picked a different author and just to go through this. Now you got to balance this, okay? So in this case, you do have a hydroxide on both sides, so you can do this now. Okay? Is it balanced? No, not quite. Okay? So what are we going to do? Just do this in our head, or sometimes just trial and error, okay? Because we have 3 hydrogens over there, so the best thing to do is get your odd numbers up to an even number, okay? So if we double this, that's going to give us 5. My math says that's still an odd number, okay? Well, I'm sorry, I'm counting this too. That's why. So yeah, it would give you 4. So if we just look at our hydrogens only, how do we get this up to an even number? If we double this, okay? So for hydrogens, 2 times 2, plus 2 more, okay? So if we have 2 hydrogens over here, or now you can look at it as a hydroxide, how many hydroxides are over here?
2,
How many hydroxides are over here?
1.
So how do we get 2 hydroxides?
You double it.
Okay? So whether you have hydroxides or whether you have hydrogens, let's just do the hydrogens. 2 times 1. 2 times 1. That's 4 according to my math, right? And we already know that there's 4 over here. 2 times 2 plus 2 gives you 4. Then the last thing is our sodiums. We got 2 over there and only 1 here. Okay? So let's go ahead and double that. Now we got that balance. Then it says how many liters of hydrogen gas will be produced. Okay? So how many liters? Well, we don't know. And sometimes it's better to use a different author here because they eliminated one step for you. We'll see if you can see where that step is because we still need to be able to see what our knowns are. Okay, I think it said 300 kelvins. Nope, 280. Okay. Is there anything else you can fill in there? You don't even have to read the rest of the problem.
0.08.
Okay, 0.0. Did you say 0.0? You did, didn't you?
It's 0.08.
No, it's 0.0821.
0. You did it again. Are you just seeing if I'm listening or what? 0.0. Okay. Okay. Then what do we need to do that? Okay. The reason I wrote it so small is that so we can do this. Once we divide that, that will give our pressure in atmospheres, which we need. And then this is the tricky part. Okay? You've never seen a problem like that. We're eliminating the middleman. And you're probably 3 steps ahead of me already when you said, yep. Why do you know that? Because you probably do. Because typically every problem that you've seen, you wouldn't start with this. You would start with what? You probably have grams. Now, reason being is this would be a very easy trap to fall into. We got this many moles. Well, N is moles, right? N's not moles? Well, you mean it's not the right one?
I don't even know which one you need. I just know it's probably not that one.
I don't know, it's just not that one. Okay, at some point you always have to be dealing with a what? You have to be dealing with a gas. What are we starting with? A solid, a metal. So we can't take that 0.74 moles of sodium until we actually do what? Yeah, we need to find how many moles of hydrogen are actually present. So from prior knowledge, how are we going to do that?
0.74 moles on the bottom.
See, you corrected yourself already. No, he said 0.74. He didn't say yeah. 0.74.
No, on the bottom, right? Yeah, it needs to be
On the top. On the top. On the top. It was on the top.
Okay?
so you can do the next step.
Now, I highly, highly, highly suggest that you do this. People still are not doing this. They do that. Don't do that. Notice I'm raising my voice for some of you who are listening. I don't know how we get this through your heads. Okay? For those of you who are paying attention, what is wrong with that? Okay? Make things much easier for yourself and do this. Okay? Now, how can we get over to this side of the equation now?
Perpendicular line, and then you need your coefficients of moles of sodium, so 2 mole sodium on the
Okay,
bottom.
so let's start with this. For every mole of sodium, you can get moles of what? Yeah, because we need to get that into a gas. And this would, and even though we're not looking for a mass, it's good practice. Put that 2 behind it. Okay? It's easy to forget about that. Oh, shoot, I see there's a glare there, but I think you can see this. We've got a mole ratio. Why is that important? Okay, so do we need any coefficients here? Must be, because we're saying that. Okay, so you need to put a 2 on the bottom, and that 2 came from this one. Okay, so now go ahead and find your moles of sodium. Take that answer and put it into here. And I made a mistake. I wrote moles of sodium over here. I meant to write moles of hydrogen. And not only just hydrogen, but moles of H2. Okay? So typically, the reason I say that is, okay, as human nature as it is, if it's late in a basketball game and you are an official, okay, a basket is just scored, okay? So if I'm doing that and I'm about ready to hand it to the ladies or gentlemen who are about to inbounds it, okay, inbounds, inbound, inbounds, inbound. Okay, that's going to inbound this. I'm going to take my finger and do what? Why am I doing this? What am I telling the person that is taking the ball out of bounds? Yeah, maybe go that way. No. The basket was made, though. The basket was made and they called timeout. Okay? That's what I mean. If it's somewhere in the middle of the game, okay, if the ball goes out of bounds, okay, yeah, it's a dead ball. Okay? And if it's in the middle of the game, you might hand it to them, and there's no pressure on the inbounds. So it's no big deal if the official doesn't do this because there's no one guarding them. But if there is 5 seconds or less left, it's just good practice. If you keep doing this, you're going to remember to do that late in the game. Okay? So that's why keep doing this. Okay? That will help you out. Okay, does someone actually have an answer then?
0.37 moles.
Overall answer.
Oh,
Okay? So you said 0.37? No.
0.37 moles of hydrogen.
That I still don't think that's. Oh, I know why.
what did you do?
Because I wrote it as 0.74 instead of 1.74. That's why I looked at you like you're an idiot. But you're not.
Okay.
But that's why I said that can't be right.
So then it's just point.
So whatever it is, when you divide 0.74 by 2, that number goes into here, and then you can find your volume. Okay? So if we change this to 1.74, get rid of the 0. So 1.74, and then put 1.74 here, okay? Then that should give you 0.87, I think. 0.87. Yes, that's what you get. Now you can solve for the volume, which should approximately give you around 21 liters of hydrogen. Okay, so we're up to 20 minutes now. For those individuals who choose to tune in, especially when we're at home, okay, if I'm doing this, I really consciously try to look at that clock because it keeps track of how long you're recording. Because let's face it, when you're at home, if you're tuning in, we got to get done with this so we can get back to our video games. And I'll be honest.
Oh,
Okay.
yeah. I play video games every once in a while.
Yeah, I don't think so. Not with that expression. Oh.
Yeah, okay, but if your dad had bought in that PS5,
Okay.
you would have been playing video games.
Probably.
Yeah.
But I don't.
Okay, you're speaking for your classmates. Rut row. Second row. Third row. Okay,
We got 20.
you should get 21.
21.
Yeah.
21. What?
Okay, so we can erase this.
Yes.
So before I forget, Mother Nature interferes, or Old Man Winter interferes, or if the weatherman is correct, what makes sense to you? The next time that you're physically in this classroom, okay, you have an exam. I hate Monday exams too, but if we keep saying, oh, we're going to take another day of review, we're not going to get you through the content that you absolutely should get through. Not because we're trying to push this content on you. The more time that you spend in here, the better off you're going to be. And I hope that we believe that, because I tell the seniors that all the time too. It's just human nature to say, I hope we don't have school because we don't have to make it up. And whether that's true or not, I don't know. But regardless, is there anything else? Oh, how soon we forget.
We got into those 2 days of the home.
Oh, how soon we forget. Oh, how soon we forget.
Bonus?
Who said bonus?
This dummy right
What did
here. You said it.
we?
Yeah.
Okay. So,
Alright, now it's I had to keep it.
Like, God dang.
I picked on a certain junior yesterday. I said, you look like you're a all-star, not all-star wrestling, WWE maybe, but turns out this individual wasn't. But regardless, I could say back in the day, which would have been in the 1980s, okay,
Would it have been funny if that was right?
Yes, but like still about the same.
Andre, you suppose that's how you spell Andre? I have no idea, but that's what I'm going with.
Over to E.
What are you, apostrophes?
Like, not an apostrophe.
Accent.
That thing. Like, directly over the E.
Oh,
Yeah.
Whatever you use in your guys' writing.
like that?
It's an accent.
Like repeating? We get the idea. Okay.
Yeah. Close enough.
Andre the what?
Or is it supposed to? Okay.
Andre the Giant.
I was like, oh no.
Okay? Since WWE is coming to Sioux Falls, this predates World Wrestling Federation or Entertainment, whatever. Okay? So since he was a WWE wrestler, obviously a pretty big guy, he was in this movie, I think it was in the 1980s, The Blank Bride. Okay? It was probably a couple. It might be. Okay. No idea if that's right.
It's not. There's like.
Yeah, I figured
I
it
can
wasn't.
never spell it though.
Caribbean. Pirates of the Caribbean.
Yeah.
Regardless. Okay?
I don't know, dude. How do you spell Caribbean?
You were close?
No, you're right. Wait, did you have two R's?
Okay? So I think it's fair to say that he was a captain in a multitude of. But when the original Pirates of the Caribbean premiered, the very first ship that Jack Sparrow was a captain of was this. In the Pirates of the Caribbean, Jack Sparrow was the captain of blank. All right, that's all I have. Exam next time you're physically in here. We will catch up to you next time. Let's hope that we are here tomorrow. We all get here safely. So we'll catch up to you then.